This is JSteele's Precalculus, Section 9.8. It's a continuation of the first part. So this is Part 2. We are currently on Example 3, and we're asked to decompose into partial fractions 7x minus 3 divided by x cubed plus 2x squared minus 3x. So again, our first step is to factor out the denominator as much as possible. So if we start off by factoring out an x, we'll be left with x squared plus 2x minus 3. Now we can also factor out that trinomial, x squared plus 2x minus 3, and we'll be left with x plus 3 times x minus 1. So writing this out in partial fraction form, we have 7x minus 3 over x times x plus 3 times x minus 1. And since we have three factors this time, we're going to have three different variables. So we're going to have a over x, since x is one of our factors, plus b divided by x plus 3, since x plus 3 is another factor, and plus c divided by x minus 1, since x minus 1 is another factor. Our next step is to then multiply by the LCD. So then once doing that, we'll be left with 7x minus 3 equals a times x plus 3 times x minus 1 plus bx times x minus 1 plus cx times x plus 3. Now we need to FOIL everything out. We'll be left with FOIL and distribute everything out. So we'll be left with ax squared plus 2ax minus 3a plus bx squared minus bx plus ex squared plus 3cx. Now if you notice, we have an ax squared term, we have a bx squared term, and we have a cx squared term. In addition, we also have the 2ax x term, we have a negative bx term, and we have a 3cx. And then the negative 3a is the only constant term we have. So then if we were to write these out, since negative 3 and negative 3 are the only constant terms, we know that we will need to set those equal to each other. So negative 3 equals negative 3a, so then we know a equals 1 right off the bat. The other equations we need to make, since there is no x squared term, we need to set all of the x squared terms equal to 0. So we're going to have 0 equals a plus b plus c. And then for our x term, we're going to have 7 equals 2a minus b plus 3c. You are able to keep all of the x's and the x squared term, or the x squareds, on, but once you divide them out, they will all go away, so you don't necessarily have to. So now, once we have a equals 1, we can substitute that into each equation. So we have 7 equals 2 times 1 minus b plus 3c. Then we have 2 times 1 is obviously just 2, so then subtracting 2, we're left with 5 equals negative b plus 3c. Also substituting in a equals 1 into the other equation, we'll have 0 equals 1 plus b plus c. So then subtracting 1, we have negative 1 equals b plus c. So now notice we have negative 1 equals b plus c, and we have 5 equals negative b plus 3c. Since we have a positive b and a negative b, if we just rewrite these on top of each other, so negative 1 equals b plus c, and 5 equals negative b plus 3c, we can easily do elimination to solve for c. Because our b's will cancel out, negative 1 plus 5 is 4, so we have 4 equals 4c, so that tells us c also equals 1. So now since c equals 1, we can just take that and plug it into the second equation. So we'll have 5 equals negative b plus 3 times 1. Certainly 3 times 1 is just 3, so then subtracting 3 to the other side, we'll have 2 equals negative b, which tells us b equals negative 2. So then our final answer, writing everything in partial fraction form, we'll have 7x minus 3 divided by x cubed plus 2x squared minus 3x, because this was the original expression that was given to us, equals a over x, which our a is 1, so we have 1 over x, plus our b over x plus 3, which b is negative 2, so negative 2 over x plus 3, plus our c over x minus 1, which c was 1, so 1 over x minus 1. So this is our final answer. So the first 3 examples talked about cases where the denominator was a linear factor. The second case is where denominator has repeated factors. Notice that there's this squared term. So for example 4, it says decompose into partial fractions. We have x minus 4 over 2x minus 5 quantity squared. We're going to rewrite this as x minus 4 over 2x minus 5 quantity squared. And since it's squared, we know that one of our terms will be a over 2x minus 5. We'll also have b divided by 2x minus 5 quantity squared. It's important to have this repeated term. We need the 2x minus 5, and we also need the 2x minus 5 quantity squared, because they are 2 different values. So once we have this, then we can multiply by the LCD, and we'll be left with x minus 4 on the left-hand side equals a times 2x minus 5 plus b, because the rest of our terms will cancel out. So then just distributing the a, we have x minus 4 equals 2ax minus 5a plus b. So then if you notice that the only x term is the 2ax, and the constant terms are the negative 4, the negative 5a, and the b. So then writing out these equations, we have the 1x equaling 2ax, and we also have negative 4 equaling negative 5a plus b. So in the first equation, we can, first of all, is get rid of the x's, and then we just have 1 equals 2 times a. Easily to solve for a, we can just divide by 2. So a equals 1/2. We're going to go ahead and box that up. So now just substituting it into the other equation, we'll have negative 4 equals negative 5 times 1 over 2 plus b. So we have negative 4 equals negative 5/2 plus b. In order to add that 5/2 over, we need to change. In order to add the 5/2 over, we need to make a common denominator. Common denominator of 2 when talking about 4, we'll have negative 8 over 2 plus 5 over 2 on the left-hand side equaling b. So that tells us that b equals negative 3 halves. Now that we have our A and we have our B, we can rewrite our final answer as x minus 4 over 2x minus 5 quantity squared equaling 1/2 over 2x minus 5 plus negative 3 halves over 2x minus 5 squared. So the biggest thing to remember here is that if we have repeated factors, you need to write them both as 2x minus 5 to the first power and 2x minus 5 to the second power. If the denominator was actually 2x minus 5 to the third power, we would end up having three different terms. We'd have an a over 2x minus 5, a b over 2x minus 5 squared, and we would have a c term over 2x minus 5 quantity cubed.